Close your eyes. Astronauts do this every night on the space station, and they see flashes of light that shouldn't exist. There's no photon anywhere near them. Yet cosmic rays punch straight through their skulls and ignite flashes directly inside the retina. That spark was matter from an exploded star, moving near light speed, striking a piece of your body. By the end, you'll know exactly what's hitting you constantly, down to the single strangest particle ever caught. Radiation isn't one thing. It's a family, from a gentle background hum to a single particle carrying as much energy as a thrown baseball. Let's meet them, faintest first. So climb the ladder with us, from the faintest whisper left over in the universe, to a single particle so violent it makes a supernova look polite. Number 1. The cosmic microwave background, the oldest light in existence. A fossil glow released the instant the universe first flashed into transparency. It happened roughly 380,000 years after the Big Bang, when the universe finally cooled enough for light to travel freely for the first time. It's everywhere, all the time. In every direction you look, the temperature is nearly identical, about 2.7 degrees above absolute zero. You've actually seen it. Point an old analog TV to static, and roughly 1% of that snow is the afterglow of creation buzzing into your living room. The CMB is the whisper. Gentle, ancient, everywhere. But whispers are where this story starts, not where it ends. Number 2. Turn up the volume. The sun isn't just light. It's a constant stream of charged particles blasting outward, called the solar wind. That wind reaches Earth in a few days, while flares also blast out ultraviolet light, X-rays, and gamma rays that arrive within minutes, moving at light speed. When a solar flare erupts, it can hurl 1 billion tons of plasma into space, enough radiation to fry an unprotected spacecraft's electronics within minutes. Earth's magnetic field deflects most of it, funneling the charged particles toward the poles, which is why you get auroras instead of a dead planet. So the sun is already trying to get you, every single day. Number 3 turns that danger into something Earth built to trap permanently. Number 3. The Van Allen radiation belts. 2 donut-shaped zones of trapped particles wrapped around Earth by our own magnetic field. Fly a satellite through the wrong belt and radiation levels spike enough to fry electronics, which is why Apollo missions threaded a careful path through them. Get trapped in there unprotected, and the radiation dose could be lethal within hours. Earth built its own force field and its own kill zone, out of the same physics. Belts trap what the sun throws at us. But some radiation doesn't come from our star at all. It comes from something that already died. Number 4. Galactic cosmic rays. Atomic nuclei blasted to nearly light speed by the shock waves of stars that already exploded. These aren't photons. They're actual matter, mostly protons, flung across the galaxy for thousands, sometimes millions, of years before they ever reach us. They hit Earth's atmosphere so hard they shatter into showers of secondary particles, some of which reach the ground and pass straight through you right now. This is what astronauts see with their eyes closed. A cosmic ray slams into the retina or visual cortex directly, and the brain reads it as a flash that was never really there. Congratulations, you've been shot by a dead star and didn't even notice. Space really doesn't ask for consent. That's a proton, moving fast. Now imagine a single particle moving so fast it makes even that look lazy. Number 5. Gamma ray bursts. The single most energetic explosions witnessed since the Big Bang itself. A star collapsing into a black hole, or 2 neutron stars that collide, can fire a beam of gamma radiation so tight and bright it outshines an entire galaxy for seconds. Point one of those beams at Earth from a few thousand light years away, and it could strip away the ozone layer and trigger a mass extinction. We've never been hit dead on by a nearby one. As far as we know, that's either luck, or we just haven't been watching long enough to know how rare luck really is. A gamma ray burst is a scream across the universe. But the strangest thing on this list isn't the loudest event. It's a single, silent particle. Number 6. The Oh My God particle, an ultra-high-energy cosmic ray detected in 1991 that, by every rule we know, should not exist. It was a single subatomic particle carrying roughly the kinetic energy of a baseball thrown at highway speed, packed into something smaller than an atom. There's a theoretical energy ceiling for cosmic rays traveling any real distance through the universe, a limit imposed by the leftover light from the Big Bang itself. This particle blew straight through that ceiling, which means whatever fired it either broke the rules or sits close enough that we still don't know where it came from. Somewhere out there is a cosmic accelerator so violent it makes supernovae look like a light switch flicking on. We just don't know its address. A whisper from the beginning of time, a death scream from an exploding star, an unexplained scream from somewhere we can't even point to. They sound like different stories. They're not. Every one of these, the CMB, the solar wind, the cosmic rays, the OMG particle, is the same thing. Energy set loose by something violent, still traveling long after the violence ended. The gentlest of them has been traveling for over 13 billion years. The most extreme has been traveling for who knows how long, from who knows where. You are standing in the wreckage of the entire universe's history, permanently. And some of that wreckage is punching through your skull right now. Yes, even while you watch this. So that flash the astronauts see with their eyes shut? It's not a glitch, not a dream. It's a piece of a dead star, arriving after a journey longer than human history, ending its trip inside a human eye. The question was never whether something invisible was hitting you. It was always just which kind, and from how far away. Space is empty, silent, and radiation-free. You're bathed in cosmic radiation, right now, everywhere. None of this is destroying you. Earth's atmosphere and magnetic field absorb almost all of it. You're not being cooked. You're being gently, constantly grazed. That shield isn't guaranteed everywhere. Step outside it. Go to Mars. Go past the Van Allen belts. Go to deep space. And every one of these 6 threats stacks on top of each other. That's the real reason a trip to Mars is a radiation problem before it's anything else. Not the distance. Not the fuel. The universe itself, constantly grazing anyone who leaves the shield. So next time you look up at a clear night sky and think it looks calm, remember it's actually the loudest, most violent radio station in existence, and you've been tuned in your whole life. If Earth's shield is the only thing standing between you and all 6 of these, you're going to want to know exactly how it works and how close it's come to failing. Subscribe, because next episode we're going inside Earth's magnetic field, the invisible force field protecting every living thing on this planet, and the day scientists caught it nearly collapsing.